Hello, I'm Tom Meeks, and this is 3D Design for Fun and Life, featuring Moment of Inspiration, using the uniquely easy Noun and Verb method.
This session is Palette 3 Verbs, Tab 1, Construct, Row 1. Boolean, Fillet, Offset, and Planar. Please note, future sessions will go into each verb in fine detail. But experience tells us that some brains can become impatient to dive right into creating. So this session is provided to give you a quick understanding of some important Palette 3 verb options in case your brain decides to take off in a fun, creative excursion. Moment of Inspiration's palette menu system, with clear distinctions between nouns and verbs, is an important key as to why our at-risk young people and their teachers found it so easy and quick to learn. In fact, it is also the key as to why anyone can create precise, complex 3D objects with so few steps. In this session, we will provide a broad overview of all the verbs found in Row 1, of Palette 3, Tab 1, Construct with this one change. In this course, to simplify things, we will often substitute the word pad for palette.
If we are to accomplish our goals to create 3D designs for fun and life, we need to be able to turn 2D nouns into 3D objects, like this early Navy blimp, and this barrage balloon for a bit of artistic fun. Or these 3D printed parts for a rare vintage car that can no longer be purchased. Items like these make our lives easier. We do that using Moment of Inspiration's powerful set of verbs, and the most used of these verbs are found on Pad 3, Tab 1.
This session is designed to provide you with a quick overview of the behaviors of all the verbs on Pad 3, Tab 1, so we won't provide a lot of detail just now. Just remember that in the upper right corner of the screen, Moment of Inspiration will always guide you with step-by-step directions. So you should have no problems as you explore each verb for yourself.
Pad 3 has two tabs. The first tab is labeled Construct, and the second pad is labeled Transform. You will find yourself using the verbs on these two tabs constantly. These verbs are the primary actions that bring 3D life to our nouns. Let's begin by opening Pad 3 by clicking on the Construct tab. When we click on Construct, the menu pad expands to reveal buttons for accessing 12 verbs, or verb groups. The first of these buttons is labeled Boolean for Boolean Group.
Before we demonstrate the Boolean verb methods, we'll point out some things to remember when using any of the Boolean methods. 1. In 2D only situations, all 2D curves must be on the same plane. 2. In mixed 2D and 3D situations, 2D curves do not have to be on the same plane as 3D objects. 3. 3D objects do not have to be on the same plane, but must be touching. 4. Some objects will disappear after a method has completed unless Keep Objects is checked.
The Boolean Group. When we click on the Boolean Group button, it reveals that there are 4 different Boolean methods: diff, union, isect, and merge. Each of these methods produces quite different results.
We usually begin our 3D designs with simple nouns known as 2D curves. But sometimes we can also begin with 3D nouns known as solids. In both cases, we will often want to modify the shapes of the original objects as we create our new 3D design. The methods of the Boolean group are frequently used for this purpose. Let's see how they work with both 2D and 3D nouns.
Boolean diff method. Boolean diff is used when we want to alter the shape of a base object by subtracting other 2D or 3D objects. Clicking on the button for the Boolean diff method begins the two-step process. Step 1 is select base objects. We first select the base object, the circle. Step 2 is select objects to subtract. We'll leave the Keep Objects option unchecked and select the objects to subtract, the pinwheel and flower. Here is the result with 2D curved nouns. The pinwheel and flower are gone, but they both cut the circle to create a new shape. Now we will do the same 2 steps with a mix of 2D and 3D nouns. Step 1. Select the sphere as our base object. Step 2. Select the 3D pinwheel and 2D flower as objects to subtract. And here is the result with a mix of 2D and 3D nouns. The 2D flower remains, but the 3D pinwheel is gone. They both cut the 3D sphere to create a new shape, but in different ways. The 2D flower cut clear through, but the 3D pinwheel only cut where it was embedded into the sphere. The holes in this earthenware vessel, designed to be printed with a full-color powder printer, were created using Boolean diff. Boolean union method. Clicking on the button for the Boolean union method begins a single-step process where we select all the objects to union. The prompt reads, "Select objects to union." We'll select all of the 2D curves in the union row and click Done. The result is a new 2D shape that combined all the selected curves. Before we try our second union with 2D and 3D objects, we'll select and deselect each of the items to show they are separate. Clicking on Union again, we'll select all of the 2D and 3D shapes in the Union row and click on the Done button. Note that the 2D curve is still selected, but didn't do anything. Unselecting the flower and clicking anywhere in the solids reveals they are now one object. The outside ornaments on this pot were painted and unioned before being circular arrayed to create this multicolor pot. While most consumer printers cannot print in multicolor just now, it still helps to use moment of inspiration style colors for documenting designs. Boolean isect method. The Boolean isect method is a two-step process, like that of Boolean diff. The first object set will be the circle shape and the second object set will be the pinwheel and flower. First with 2D nouns only. Only areas intersected by two or more 2D nouns remains. And now the mix of 2D and 3D nouns. The 2D flower remains selected, but this time it defined an area in the base 3D object to retain. The 3D pinwheel solid is gone, but it left behind the part that intersected with the base object. Boolean isect applied multiple times to a sphere at 16 different angles made designing this multifaceted gemstone possible. Boolean merge method. Like Boolean union, Boolean merge is a single-step method. We'll select all of the 2D objects in the merge row and click Done. At first, it appears as if nothing happened. But exploding the many parts shows a different story. Now, let's see the results of using the Boolean merge method on a mix of 2D and 3D objects. Exploding the parts in this result is even more interesting. While Boolean union and Boolean diff are the most used Boolean methods, you can see why we also included isect and merge in this introductory overview. Boolean merge was used early in the development of this playful design created just for fun.
The Fillet Group. When we need to add a bit of finish to sharp corners, we use fillet. There are two methods in the Fillet Group. Both are three-step processes that alter corners and edges. The fillet method. The fillet method rounds sharp corners on 2D objects, and with 3D objects, we can apply the fillet method to entire objects, faces, or edges. Step 1. The prompt says, "Select objects to fillet." We select the star and click on Done. Step 2. The prompt says, "Select corners" or push Done to do all. We want all, so we'll click on Done. Step 3. Pick fillet radius. The radius value we give it must be small enough to fit the size of the selected object. Note that a value of 3 does not work on this 2D curve, so we'll try a value of 1. Let's see what fillet does to an entire 3D object. The chamfer method. With 2D curves, the chamfer method chisels features, defined by corner points. We use a similar three-step process, but we also have an added option to define two distances. Note that we can use a value of 3 with the chamfer method on the identical 2D object, but it doesn't create the shape we want. We'll use a value of 2. And we'll also use a second distance. This time we will use a value of 3 to create a sawtooth effect. As with the fillet method, with 3D objects, we can apply the chamfer method to entire objects, faces, or edges. This drone is a great example of a finished look made possible by the fillet method, and the chiseled features of this simple castle were easily created using the chamfer method.
The offset group. There are 3 methods available in the offset group. The offset method. The offset method creates a new object based on the profile of an existing object. Clicking on the Offset Method button brings up the prompt, Select Objects to Offset. Selecting an object and clicking on Done brings up a new prompt. Pick Offset Side, and we are given a chance to choose a distance value. We'll enter 2. We generally use the mouse to move inside or outside the base object to select the final result. It works with both 2D curves and 3D objects with some slight behavior differences. This stacking toy was created using the offset method to create evenly spaced sizes. The shell method. The shell method hollows 3D objects by an amount that will leave walls defined by the thickness value. The prompt reads, Select Objects to Shell. Selecting the object and clicking on Done brings up the prompt, Pick Thickness. This value defines the thickness of the wall to be left. Note the faint lines indicating the area to be hollowed. We will cut the 3D object we used to demonstrate Shell's result and prove that it worked. This fun fantasy creature was made possible by the shell method. The inset method. The inset method only works on faces of 3D nouns. Actually, the name inset method is a bit misleading. That's because it works in either an inward or outward direction. We'll select the top of the box using a thickness value of 2. And check the Use Separate Height option. The box is 15 mm cubed, so to leave a floor of 2 mm, we'll enter a value of 13 mm and click Done. To create the top for the box, we'll change the direction to outwards and use a value of 2.4. The reason for the 0.4 increase is to allow for the way consumer FDM 3D printers work. We'll explain in another session. Both box and top are complete. Alternating between inset and outset produces interesting results as we see in the surface of this orb.
The planar verb. The planar verb creates a plane from a closed curve. It will not work with open curves. A plane by itself cannot be 3D printed. It has no depth. But we can combine planes to create solid objects. We'll use the curves in this sample to create a pyramid by selecting each triangle polygon in turn and applying planar. To make it easy to select all the polygons, the one on the bottom has been lowered a bit. We'll raise it to meet the others. Selecting all the planes, we see that we have 4 individual surfaces. But we can turn these individual surfaces into a solid by applying Boolean union. While this design cannot be 3D printed, it does demonstrate that planar can be used with a variety of 2D curve shapes.
This ends the session on the first 4 verbs on Pad 3, Tab 1. I hope you found it helpful and encouraging as you explore 3D design for fun and life with Moment of Inspiration. Our next session introduces the very important and fun extrude, revolve, loft, and sweep. Thank you for joining us. Tom.